Good evening and welcome everyone. I'm Tim Green. I'm Director of the Energy Futures Lab here at Imperial College. The Energy Futures Lab, as I think many of you will know, is one of Imperial's institutes, and that means we have a role to bring together the researchers and teachers across the campus who are interested in energy to tackle the major challenges that are facing the way we provide energy to the citizens of the world. Today, we're gathered to celebrate 10 years of a fantastic MSc in Sustainable Energy Futures. It's an MSc that is unique in its provision, I think, and has now graduated over 400 students who've gone on to very interesting careers around the world and in all sectors of the energy industry. I think the core strength of this master's course is the fact that it brings together experts from so many domains, each of whom is tasked with explaining and showing how their particular speciality plays a role in the energy system as a whole, and how the system comes together to provide low carbon and affordable energy. It's not just the teachers that are here on the campus. They're a large part of the delivery, but we also engage with academics from other universities, from guest lectures from industry and from government. And it's bringing that group of people together, I think, is what makes it particularly special. And we're extremely grateful to the efforts that they put in. And I think it works well because our feedback, particularly from our guest lecturers, is that they really enjoy the interactions with the students and the quality of the people that they meet through that, and indeed the quality of the people that they very often go on to employ a little while later. Of course, there's other people that we're very grateful to as well. So the people who help us administer the course, Gavin and Tanisha, but also the course directors. And this course was established, as I say, a little over 10 years ago. We have the founding director of the course, Sandra Macchietto, who will say something in a little while. That baton was passed to Andy Hayes and then Johannes Spinnaken, and now the baton has been passed, well, in the recent past, to Graham Hughes, who you'll hear from in a little while. All these people have contributed to making the course what it is, but it really is the alumni, I think, who are the best advert we have for what happens. We set out to educate and inspire a generation of leaders within the energy industry. And in keeping with that ethos and the name of the course, Sustainable Energy Futures, we're holding this panel debate on how we are building a sustainable energy future, which Graham will chair in just a moment. When the debate closes in about an hour's time, I invite you to join us back in the Great Hall to see the rest of the exhibition, the stands you might not have had a chance to see yet, and to join us for some refreshments. But now I'll hand over to Graham and our four guests, who Graham will introduce for the rest of the proceedings. Thank you, Graham.
Thank you, Tim. So thank you very much and welcome. Thank you for coming and welcome. As Tim said, my name is Graham Hughes. I'm the current Director of Education in the Energy Futures Lab. And I'm sort of responsible for looking after the MSc in Sustainable Energy Futures. So we've just completed the first year that I looked after that, and very pleased to say, well, now the second cohort is, that I'll be looking after is well underway. So it's a pleasure for me tonight to introduce at this showcase event 4 past alumni who are here to tell us about their experiences post-SEF and what it means to them, and to offer their views on our energy future. I think I particularly want to say thank you to our alumni who have recently set up a fund, the SEF Alumni Fund, and that is, the intention of that is it's available to support students in the current cohort at any one time. So please join me in thanking those alumni who have contributed to that. Okay, so without further ado, get on and introduce the speakers so you can hear from them. The first speaker is Andy Hadland, who is a class of 2008-2009, or 2008 to 9. And he was originally an energy engineer, now working at Arenco, a fast-growing energy storage company. So we'll probably be hearing something about energy storage from Andy. The second is Peny Panagiotakopoulou, the class of 2009-10. She is a market modeling manager at National Grid Ventures and is responsible for defining, building and analyzing investment cases for interconnectors or distributed energy projects. Iván Pineda, the class of 2009-10, is now the Director of Public Affairs at Wind Europe, a leading renewable energy industry trade association in Brussels. And the fourth speaker is Elena Giannakopoulou, the class of 2010-11, and is now the lead of energy economics team at Bloomberg New Energy Finance. So please welcome all our four speakers, and I guess we'll be hearing from Andy first. As you like.
No, I can.
So
I'm not Andy.
we'll mix it up.
So this is an interesting question, and I tried over the weekend to think about this because we not spent much time very often to think about the big picture. And in the interest that I am, we're doing analysis, and we are trying to look at the big questions that keep people awake at night. So there are people that are talking about the energy trilemma. I'm sure that you have all come across this phrase. There are some others that are talking about the 4 Ds of the energy sector. So the decarbonization, decentralization, digitalization, and the democratization of the grid. Regardless the framework that someone can use to think about the sustainable future, in my opinion, they all share the same principle, which is that we need more than one technologies. We need more than one sector or one group of people in order to get there. As Graham mentioned, I am leading the energy economics team at Bloomberg New Energy Finance, and what my team is doing is analyzing the medium and long-term dynamics of the global power sector. And as part of this, every year we are producing a long-term forecast. And the key messages that are resulting from this work is that there are a number of game-changing components today in the system. So transitioning to a sustainable future is beyond solar and wind that is getting cheap. It's even beyond batteries that are getting cheaper and cheaper. It's about consumers that are becoming more powerful and more mindful, that they install PVs on their roofs, they install batteries. It's about our phones, our white appliances, everything that is getting more and more efficient. Is about EVs, a whole new market that is knocking our door. It's about cities that are becoming smarter, resilient, more efficient. And every time that I'm talking to our clients, that I'm presenting these key findings, the questions that I'm getting is not, are you sure? Or how is this going to happen? Or is this really going to happen? Are we transitioning to a more sustainable future, to a low carbon future? The questions that I'm getting and the concerns that they have is how much, how fast this is going to happen. So overall, what we see is that the whole discussion about the sustainable future has evolved from a topic that was initially dominated by environmentalists to something that is embedded into the industry, into the economy levels. But in order to get there, technology is not enough, and we need to ask the question, do we have enough technologies today? So we need new business models, we need new decisions in terms of investments, we need new policies. Overall, it's a longer-term discussion, but we need to tackle it with the options that we have today, if you want. And when I'm thinking about all these challenges that the energy sector is facing, how we're going to get to a sustainable future, in my mind, it's like a marathon race. So to succeed, we need to think about the long term, and we need to make decisions as we're getting there. And that's exactly what I feel that I learned at SEF, to assess the different options that we have. In my year, our courses cover technologies from coal and gas to PV, that back in 2010 wasn't a pretty standard technology to talk about, and to CCS, which today might not be as a hot topic as it used to be, but we covered a number of solutions. And what I learned here was how to analyze data, how to talk to people that have completely different backgrounds and way of thinking, but also how to focus on the big picture. So, closing, I think that if the energy sector and our transition to a more sustainable future is a marathon race, this place has been, for me, the ideal, the most amazing training ground. Yeah, all the skills that I got today, the most of them, I got them in here. So that's all from me. Thank you.
Thank you. And thank you to the Sustainable Energy Futures for inviting us. Thank you, Professor Hughes and Professor Green, for having us here. It's really a delight being back at university. And it's really a delight seeing so much interest of this generation that is coming out with a single vision, you know, the vision that things can change. And this change, this transformation, it's in your hands. And it's extremely important that you realize the power that you will have once that you go out there to the real world. Because you will face those difficult discussions, those difficult questions about how much, how fast, when it's going to happen. In our time, when we were graduating, these discussions were not taking place. It was more exactly about why to do it and how to do it, and why is there a need of doing it. I graduated in 2009, 2010, when actually we were coming out from the failed COP in Copenhagen. Some of you might remember, some of you might not remember, but in 2009, governments around the world got together because they realized that they wanted to solve climate change. And that meeting in Copenhagen, that was particularly branded as Copenhagen, didn't take place, didn't have the impact that it should have been. There was a clear misalignment of interest between governments and leaders about what to do on climate change. I was also graduated in a world where energy didn't matter because we were coming out of the financial crisis. Who is thinking of a smart meter when, you know, the stock markets are collapsing? Who is thinking about distributed energy when we are at the doom of all the banking system? I was also graduating in a very different world where smartphones were not the rule. You have, all of you, a supercomputer inside your pockets. There was no Tinder in my time. I had to go and talk to people in the bar. So it was a very different world, and all this change has come so fast that it's very difficult to make sense of it. So one of the important aspects that I've learned here in the Energy Future Labs is just not only make sense of things in the great picture, but also be able to explain them, and to explain them in a very easy way. That's my job today. How I am building a sustainable future, I go and talk to people and explain to them what they consider as extremely difficult to understand. And that's your biggest challenge, because you will always be able to do the models. You will always be to do the assumptions. You will always be able to do the literature review and find the best reference. But when someone is telling you, can you please explain me what is reactive power again? And this person has probably no background whatsoever in engineering, that's when your skills will come to play. My work is to talk to people that actually are making laws, regulation. I am the lobbyist guy. You know, I work in Brussels. I talk to members of the Parliament of the European Union. I talk to the executive arm of the European Union, the European Commission. All of these people, of course, sometimes they are not very famous in the UK these days, of course, but I have to go and talk to them. And I need to explain them what on earth is balancing energy, what on earth means grid service, what on earth is an interconnector. What does that mean, a cost collapse of batteries, in very simple terms? So my path, when I graduated, was exactly that, is making things accessible. I want to make awareness of the important topics of energy. I want to build capability out there. And I want to ensure that those people that have enough power to make decisions that will affect all of us understand the consequences of their decisions. So I go and I represent the interests of people and companies that are active in wind energy. That's my job. I am the wind guy. I go to conference and I talk about wind energy and how great is the technology, how advanced has become the generation of wind, how great could be our future if it's more sustainable, relying on renewable energy. And this is how I chose to build our sustainable future. I also, in many occasions, advocate for evidence-based policy to ensure that people have the right facts. Sometimes lobbyists are idolized, are also darkened, like these evil agents that they go about in Brussels talking in the halls and influencing and corrupting legislators. Well, actually, the most important thing that I do in my day-to-day job is sharing information of things that are happening out there. That's the job, but that's probably the job of all of us. It's just explaining things to people. And that's what you need to understand, that if you are able to solve incredibly difficult mathematical problems, 2 or 3 level optimizations, you need to be able to explain to somebody else out there that has the power of decision, what does that mean? What are the consequences? Thank you.
Okay, thank you for the invitation as well. And it's a great pleasure to be back here where we actually started our kind of career in the sustainable energy. So for me, after the master, it was more around the markets, the European energy markets, and how different drivers affect the outcome of the whole picture. So having got the basis here, seeing all the different technologies from coal, nuclear, wind, solar, and how these different technologies interplay into the market was a great starting point. So today we see a different market compared to what it was a few years ago, and we try to forecast how it would look like and how the European markets or UK market would look like in the future, in order to be able to advise investors or actually take investment decisions for the company that I work on. Whether this would be in the interconnector case, bringing renewable energy into the UK, or if it would be battery storage, or if it would be more like distributed energy, like a wind combined with the storage. So it is important to understand how these different technologies develop. We see the cost dropping, and therefore batteries becoming an attractive option the last 1-2 years. We see wind costs falling, and we even see now investors being, or utility companies accepting to take a risk and build merchant wind farms without the support of any subsidies. So all these are very different today compared to how they used to be a few years back, and the world is going to be much more different as we go in the future, given also the electrification or the digitalization of the energy. So trying to assess all these different technologies and how one will act together with the other and which one would be the winner in the market in the end will help kind of decide on what the sustainable future would look like. Thank you.
Hi everyone, thanks again. I'm usually back at Imperial a few times every year, so it's good to be back once more. I'm actually probably not going to talk specifically about batteries right now, but obviously might pick it up in the questions later. So when I did my thesis back in 2008, I did it on marginal emissions across the entire UK electricity grid. And I remember back then, the amount of renewable generation on the electricity grid was around about 3%. When I looked last year, or for 2016, that was up at 24.2%, which is fantastic. You know, we've made great progress over the lifetime of the course. And some SEFers can take credit for that. You know, other manufacturing costs coming down, that's fantastic, I think. With the EDF Hinkley Point deal, I think there were 3 SEFers on the 7-person team that negotiated that for EDF, none on the government side, so maybe they should have had a few more SEFers. But I do think that whilst we've made progress in putting renewables in, going from 3% to 24.2%, what about the workforce that's behind it? You know, if you look at the most recent stats, there's 9% females in the energy industry. There's 50% on the planet, something's wrong there. There's 6% from ethnic minorities in the UK. So whilst we're making a lot of progress on diversity of energy sources in the energy system, how much progress are we making with the people that are behind that transition? So I just want to leave that for you. It's a nice little metaphor to play with. A second point would be, I liked your point about the technology is not enough, and I completely agree. I think back in and around 2008, Stern time, it was about convincing the middle class that climate change was a thing so that the middle class could do something about it. So if we look at SEF, it's actually quite diverse in some senses. There's lots of nationalities. But then there's also a lot of relatively middle class, metropolitan, highly educated people. There's lots of other forms of diversity that could come into that. Age, income, orientation, there's disability. There's loads of different types of diversity that perhaps SEF could improve upon to represent the energy system, which I want to ask a question now. So hands up who has control of their energy supplier at home. If you can put your hand up. A little higher. Okay, now keep your hand up if you're on a 100% renewable tariff. Okay, that's half. You should look at that. I think in this room we have, we have a generally highly educated metropolitan group. But is what we're doing, is all this technology building a sustainable energy future for everybody? Because fuel poverty is still a thing. Back in 2008, fuel poverty was a big issue. What have we done to actually really address that? I think all of our policies have driven up costs. Over half the cost of energy that consumers pay is in a tariff of some sort or another. So when we say we're building a sustainable energy future and how we're doing, we are making progress and we need to work there, and that is fantastic. But we need to build a sustainable energy future for all. And if we only have a certain cross-section of people solving those problems, then how are we going to see it? How are we going to come up with the solutions to those problems if we're not affected by them? Because I can afford to pay a little bit more for a renewable energy tariff, but not everyone can. So the solution that works for me won't work for other people. And I think that's a big challenge for the entire industry and something that we all need to work on. So perhaps I can encourage you, this week when you go back to work or wherever you are, to try and get a perspective from someone other than the people that you usually ask, someone at the other end of the spectrum who might offer you an alternative viewpoint. Because necessity is the mother of invention. If people who are actually directly affected by these issues, there's 1.2 billion people without access to electricity in the world, but the balancing services cost and capacity markets don't directly affect those. So yes, I'd like to kind of leave that as a point to consider, as a bit of a rallying call. And I think also that's where the alumni fund, the SEF alumni fund, comes in. So obviously, those who have gone through the course that are working in the sector could perhaps contribute towards that fund, and then anyone who contributes towards that fund would have a say in how it's spent. So for example, if we're getting a certain demographic of people through the course, educating them in this arena, giving them the tools to be conversant, perhaps we could widen that net somewhat using that fund or perhaps other mechanisms. So yeah, a slightly different approach, but one that I think is very important. Thank you.
Okay, so thank you very much to the four speakers for that introduction. Here's where we turn to questions from the audience. And depending on the numbers, we may choose to take them 2 or maybe 3 at a time. So who would like to start off with the first question? So one up here. And we have two roving microphones. So perhaps if you have a question, could you state your name and affiliation, and away you go.
Hello, Darren Gray with the Alan Turing Institute. I'm wondering about the panelists, how they feel that the course, the SEF course, best helped them in their careers.
Okay, so
Should we get more questions, or we one by one?
that seems, I think that's probably a very good opening question that we might like to hear from everyone there. So,
Well, you have the mic.
Okay, how did it help me? I studied chemical engineering first, and then came straight in to do the masters. And I think the thing that attracted me to it was that it was kind of like an MBA for energy, was how I kind of viewed it. And I really liked the concept of building up a toolkit of policy, of engineering, of modeling, which was quite ahead of its time, I think. So well done, Sandro. People are now saying you need to be able to code, but this was in it from the start. And then the idea of having all the different technologies and being able to be conversant kind of rewired my brain, I would say. And then I found that incredibly useful because throughout my career I've worked on electric vehicles, energy efficiency, combined heat and power, biomass, and now battery storage. That's a huge different range of technologies, and the thing that links them all together is SEF and being able to see where the gaps are and how I can draw lessons from one into another and how I can compare those two. So I think that's probably the biggest thing that I had from the course directly, I would say.
So yes, my background as well is electrical engineering, and I would say that doing the course enhanced this element of policy analysis and going outside of the full mathematics or physics or all the equations and solving the power systems problems, just seeing the bigger picture, so the whole energy system, and have the wide range of technologies out there, but then also take it one step further and see the policy around that. So I remember an assignment was like having to respond to a consultation from Ofgem was kind of a great example of actually putting this into real life and see how you would go in reality to use all this theoretical knowledge or this literature review to actually respond to a real issue out there. So this, I would say, was a main.
Fully agree with what you have said. I will add 2 elements. Networking. Look around you. You are going to be the people that are going to be working on this in the future. So in the same way that we are doing our little a contribution of sand in the desert to make a sustainable future, that's exactly what you are going to do. So network as much as you can with people in the same tone as you said. Talk to as many people as different as you can. Get other views. That's extremely important, the diversity in the networking. Because while you might be able to solve mathematical problems and you might be brilliant on paper or in your computer, the interpersonal skills that you can get here will help you out there. So get the knowledge, get the critical thinking, get the networking, but importantly, you need to distinguish the noise from the facts. Nobody is going to teach you here what is a real issue from an invented or perceived issue. And one of the greatest learnings that I have working now in the way that I work is that sometimes there is no issues that I need to solve. I need to find what are the issues. And nobody in the university has told me how to find problems. Everybody told me how to solve problems. And you are trained to solve problems. But when you are actually identifying the issues, there are two types of good engineers and scientists out there. The good ones that save you money, but the best ones that make you earn money.
Not much for me to add, right? So I would completely agree. I would only say that there was a project, a group project that we did in my year, which was about the optimization of the UK energy mix. And when we got this project, I went, what's that? And why? I couldn't imagine that this will become my full-time job. But my point is that when we started thinking about this, it's exactly what you said. What's the problem? What I'm trying to solve? And there were 5 people with completely different backgrounds. I was the only engineer. We had people from with theoretical backgrounds. And I couldn't see how all this fits together. So questioning the topic, questioning the group, questioning everything, I really had a hard time. But then when we completed the project, I could see how all this comes together. And I think that this was, if not one of the most valuable things that I did at SEF. And help and set the base for my future career.
Okay, thank you. Who would like the next question? So up the back.
Very good evening to you panel. Thank you very much for the opportunity to be here and for a riveting presentation. Sorry, one moment. My question is twofold, rather. First pillar is how do we build a future-ready workforce to tackle the challenges ahead in terms of climate change, dwindling fossil fuel resources, as well as cyber security? And secondly, how do we transition the past and current workforce, by that I mean the fossil fuel industries, into the zero carbon industries of the future? Thank you.
And is there a second question that we'll take at the same time? Okay, who would like to address that?
I'll give it a go. And I'll give it a go through an example. Is there anyone here from Poland? Okay, so I've been to a beautiful country in Poland, talking to people in the energy ministry that are asking exactly the same question. Poland basically depends 80% of the energy mix on coal, lignite. Okay, have you ever seen the dust that comes out of that combustion? You don't really want. It's really, really nasty. And one of the biggest issues that policymakers have there is how are we going to let all these people off from jobs that coal mines and coal power plants create in our country, and you are telling us that now we need to install solar panels and windmills, how we are going to address this transformation, this transition, in a way that not affect all the jobs that we have. And it's a genuine, difficult question, because when we put out there a wind farm or a solar PV power plant, the level of scale could be as big as a coal power plant, indeed. Okay? But not everybody would have the same level of capability or training to actually execute that job. So there is no real easy answer for the transformation on that. And one of the important things that governments, we tell governments and leaders and decision makers in companies, they need to realize is that they need to anticipate that technological change. It's not enough saying we have here our little mine of coal that will survive for the next 10 to 20 years and I don't want that to change. There are two ways that comes in politics. So when a problem comes in politics, the first reaction is to ignore it. Okay? Then the second reaction is to delay response or to leave it for tomorrow. And those challenges, when you are a professional that is working either for the private sector or when you are an engineer, are completely against what you've been trained for. You are looking for solving problems. You are looking to get things done. Well, out there is not like that, okay? There will be people that they will ignore problems in the hope that they will go away. And there will always be say, okay, we will solve it tomorrow. And this is what is happening with that specific question. I don't have a clear answer, unfortunately, but it's a very valid question, and we should all be thinking about how can we transition our workforce that actually is out there still based on a fossil fuel economy to renewables.
Yeah, I would like to add something here. I think, as you said, with every change, people either ignore it or there is a lot of inertia. So let's not deal with this now. But the thing is that it's a new era and they need to identify not just the risks, but also the opportunities. Because this question, similar to you, I get this question very often, what are we going to do? And one thing is to identify the right problem. So is it renewable energy the right problem? Or is it automation a problem that they already face? For example, in the mining industry, a lot of jobs are replaced by machines. So are you looking at the right direction? Is it really renewable energy the problem? And the second is, what's the opportunity? So for example, we have batteries, we have EVs, and all this means that we need new materials. So why do you need to be attached to your coal mines? You can take advantage of the workforce, of the knowledge, and improve it, and build on the top of this. And for example, start mining, I don't know, lithium or nickel or something else that will be needed. So usually that's the discussion that I have with our clients. Don't ignore the opportunities that may arise, because what we saw, for example, in the electricity sector, we saw utilities trying to push hard and put some barriers to renewable energy, and then they found themselves in very difficult position, and eventually they had to adapt their business models, they had to tap into new markets, into in new services. So I think that overall we need to look at the right place and be how can we leverage it, how we can make the best out of it.
I'll take the other end of the question. How can we build up the workforce from the bottom up? I think it's well known, the skills gap. There's a consultation out. The government have been gathering evidence on it at the moment. Pick a number, around about 100,000 new people are needed to help manage this transition and to a clean energy future in the UK alone. And that is a lot. And then if you look at the stats from the Royal Academy of Engineering, tomorrow's engineers, STEM ambassadors, you see that kids, when they are in year 6, so 10 or 11, about 75% of them go, science is cool, I learn stuff. And then when you get to year 8, that drops off below 50%. That's a 2-year gap. What's going wrong? And then when you get through to higher education, you're down in the 20s, teens, for people that would consider science and maths as a career. We're losing something there. And it's really interesting because I don't know about you, but when I go to the pub and I talk to my friends, I enjoy my job. It's creative, it's problem solving, I get to kick things that we build. The hours aren't completely ridiculous most of the time. I mean, it's actually quite a cool job. It's quite a good profession to be there. Yet it somehow gets labeled as sort of geeky and numbers based, when actually there's a lot of communication, there's a lot of problem solving in it. And that's the kind of thing that a lot of humans like. And if you end up pursuing careers, because quite a few engineers that I know end up going into perhaps financially richer professions that offer, you know, a fast track to a midlife crisis and early retirement. I'd much rather enjoy what I do. Life's too short. And we all know this. That's why we're in this room. But why aren't we going back into schools saying science and maths is cool? You can do fun stuff with it. Some of you may know the electric car project that I was involved with, where we built and raced an electric supercar. That's using maths and numbers. And it's cool because it can do a Ferrari off the line quietly. You know, there are these things that we need to be going into schools and making sure that we're not losing interest. And anyone that's involved in the sector, you will also be enjoying your job, I hope, on balance. And if you do enjoy your job, then you want to accelerate this transition, then go into schools and be a STEM ambassador. Is anyone in the room a STEM ambassador, or have they gone into schools? Yeah, so what, 5%? It's scary, but it's actually fantastic. Because if you only need to go in once a year, and you get to talk about what you find interesting, and you know, you might hopefully get more people excited about science and maths than you put off. But if there's just one kid that you inspire to take on that career, then I think it's worthwhile. So that would be the other end of the problem.
All right, another question down here.
Hello, Adam Chase from E4 Tech. We're a consultancy firm. We're also one of the most faithful recruiters of SEF graduates. And that's not just because we're tribal. It's because we advertise most years, and we get applications from all over the place. And it's very nearly always an SEF students and the ICEP students, energy policy option master's students, who rise to the surface. So thank you for delivering great candidates. The last came on board 2 weeks ago and he's already buried. I actually want... I wanted to ask the panel what thing they would guide the designers of the course to add. What thing, whether it's a technology or a capability, a skill, a process, a discipline, what's the one thing that you would like to see, given all this change that there is and these future challenges? It's not an interview question.
I'll kick it off. I've also generally worked at Energy Excel, Amoresco, and we have a fair few as well. And so it's quite interesting seeing over the years what the skill set does and how it changes and how it evolves. And I think one thing that the course has done is it has evolved over the time. So in my year, we didn't have any business skills, and that was a bit unhelpful. And then that's been added to the course. And there's also some team working things with Mark Workman and the Army training. But I think the piece that I think would be helpful is a commercial angle, a legal angle. That's how a lot of things get done at scale, and legal training on what is a heads of terms. What does an NDA look like? How do you do that? How do you progress and make it happen? And I think that could be something that could be added in a week. Get some specialist energy lawyers in and add it to the curriculum. It's not like there's enough to fit in already.
Two things. One geeky, one more philosophical. Geeky first. I think we are already, I haven't checked the latest syllabus of the program, and most of you are already exposed to a high level of coding. But this is the future. It is already here. So whoever is not able to code basic information, apps, routines that simplify internal processes in your own industries is going to be behind. You know, you need to be able to code in a couple of languages. So for me, that's a key one, and it's already coming. That's a key one. And the more philosophical is that you need, and this is particularly because of my experience, you need to be able to get arguments across effectively. So debating classes. I have 2 Greeks next to me, okay? These are the foundations of good science, being able to debate, question, and get the things to the root.
Yeah, I mean, I couldn't agree more. And because we tend to try and communicate and make our arguments using a lot of numbers, just throwing numbers to people until they get exhausted and they start agreeing with us. But you're totally right. And because we are smart people, we tend to get down the rabbit hole, as I used to say, where it's all about numbers. It's all about this teeny tiny thing that's smart. Very few people know that I know because I did at my master's, and how come other people don't and why they don't understand it. So yeah, I would totally agree. More training on how people come across and communicate very complex topics in such a way that someone could understand what the problem is and how we can possibly solve it. Yeah.
Yeah, basically, I would agree with the last point too. I think we had some debating classes when we did the course, so I'm not sure if this is still on, but for me the key would be how you would translate the most complicated issue, the most complicated problem into a simple language that anyone could understand, that with different backgrounds, different level of seniority in the company, or like anyone that would be in simple terms clear.
Okay, so now I've taken notes about what we need to do with the course. I'm glad to say we are doing some of those things at the moment. But who would like the next question? Just someone up here.
Hi, my name is Clea Colster. I'm a PhD student here at Imperial, also an alumni of the chemical engineering course here. So my question is to the panel, but picking up on what Andy said with regards to the lack of diversity both in the sector, so be it ethnically, income-wise, or gender-wise. And you mentioned the fact that 1.2 billion people in the world still don't have access to electricity. I think 2/3 of which are in sub-Saharan Africa. And so my question is, how do you guys think that you are helping address this problem, which is part of this sustainable energy future? Or if not, how do you plan on doing that, and what you think that we can do more of in that respect? Thanks.
Perhaps in the interest of time, we'll take the second question.
Cheers, thanks. Iván Finnell, I'm the Managing Director of ABB Limited in the UK. Can I first maybe congratulate the college for having the vision to create the program? I think this is, 10 years ago, you have to think about where we were 10 years ago, and I think it's a fantastic legacy that the college has created. And secondly, to thank the panel for a fantastic introduction and some great responses to some challenging questions. I'm glad that some of the points have been raised in terms of how we move this whole program forward. We've talked about regulation, and regulatory changes have an incremental impact on how we view the energy future. Government policy also very much an incremental change, and technology, and ABB is a technology company, also has an incremental change. But I'm really glad that the commercial aspect was talked about earlier, because what I'd like to understand from the panel is where they see the disruptors in the future, not to drive incremental change, but to drive a step change. Where are the Ubers or the Netflixes or the Airbnbs in this sector? Are they in this room?
I'll pick up the diversity point. It's really hard. We are, as a company, not doing anywhere near as well as we should. And I think the first step is acknowledging that and not being afraid to say that we should do better. And then sharing our experience as we go along. So we're actually working with another company on the recruitment side, and we're working with the Renewable Energy Association to, first of all, what is diversity? What can you say? What can't you say? How do you talk about it if you don't know? So we're going through that process, and we're also trying to make sure that we're inclusive, because actually I think the diversity debate should move on to being inclusive. So if you're inclusive for everyone, then diversity will follow. And so that's where we are right now. What does that mean practically is where we're at on the journey. I mean, there are simple things you can do internally, like making sure if you're running an activity, or there's lots of like micro conversations that go on that you might not realize that you're excluding somebody. If I keep talking about something that I want to do the entire time, I'm just going to pick a very generic one like football the entire time, that may or may not be inclusive to everyone who's not involved in football. If we set up a work football team, actually FA rules, you can't play adult males and females together for insurance reasons. So is that the most inclusive thing to do? So making sure that you're doing more inclusive things, I think is part of it. And also looking a little bit harder when you find people that want to join the business, and saying that you're on a journey. I think that if you take the view that talent is evenly distributed across whoever, everyone, and if you just take the gender gap, then if you've got 9% females in the energy industry, but there's 50-50 out there, there's 40% of super talented people that you're not getting. And why aren't they're there? They'll be around. So it's just a question of looking hard enough and opening those conversations. But as for what the final answers are, I don't know. I think the debate is quite immature on diversity and inclusion. I see it as sort of health and safety from, in the 1980s. Like, oh, this is a sort of, it's not important to wear a hard hat, it gets in the way. Whereas actually, we've all become quite comfortable that actually to run an operation in a safe way is good business, and it's inclusive for everyone, and everyone goes home safe. And I think diversity and inclusion is at the start of that journey. So if anyone has any ideas as well, I would love to hear them. I'll leave the other questions.
Thank you. Okay, thanks. So regarding these 1.2 billion people that don't have access to electricity, to be honest, I think that we are underestimating what is happening in sub-Saharan African countries, in Southeast Asian countries, in order to bring electricity to people. There is a lot of innovation. There are a number of companies that are now trying to get there. There are a number of investors, mainly developing banks, that are trying to help. So, for example, our role, and coming from BNF, what we are doing is analysis. So our responsibility there is to communicate to our clients or to people that are following us, attending our conferences, that the cost of the technologies are coming down. Rightly or wrongly, this is a new market, when developed markets for people that are in the energy and the electricity sector are not growing at all. So for them, it's an opportunity opening to a new market. There are people that don't have access to electricity, and if you want electricity, it's the first thing that you want to give to people if you want your nation to develop. Technology is getting cheaper. I mentioned that earlier. PV costs are coming down, battery costs are coming down. There is a lot of innovation, if you want. And I think that if we communicate what is happening, and if they get the right information, so Andy, I agree with you, regardless of talking about inclusion or diversity or how we get electricity to develop to emerging countries, information is the key thing. So we need to make the energy stakeholders aware that they can do it, and this is good business for them, because when it comes to companies, they need to know that this is good business for them. So yeah, I would say that don't underestimate what is happening in this part of the world.
Likewise, I agree. We should not be satisfied. Indeed, there are many things that need to be done. There are many challenges ahead when it comes to providing electricity to a lot of people around the world. But two important aspects. that I also relate to what has been said. Number one, I consider myself an ambassador of communicating the potential of technologies out there, the reduction of technologies, and not only generation technologies, not only PV panels or wind turbines or battery packs. There are many other technologies that are coming down that will enable these technologies to thrive in markets such as Sub-Saharan Africa. Communication technologies, sensors. Sensors are getting super cheap. How many sensors you have in a smartphone? Anyone? How many sensors? Who gives more? Who gives less? There are about 40 sensors, cheap sensors, in your iPhone or in your smartphone. Pressure, humidity, movement, vibration. When you pick up your telephone and you put it on your ear, the screen goes off, so to save battery. So sensors are one of those technologies that are coming extremely cheap, and they will be the enablers of having a solar PV panel that is going to be communicating with your kettle, with your toaster, with your boiler. Those sensors are the enablers to get a sustainable energy future, not only here, but also in other countries, because as the technology comes down, they will be by far more affordable. So I do feel that responsibility of going beyond the things that you can see on the rooftops or the things that you can drive electrically, but communicating other types of technologies. You know, fiber optics now is common for us. You know, satellite communication, like something that we deem business as usual. You know, but these technologies were extremely expensive. I mean, extremely expensive a few years ago. Now they become very cheap. So indeed, cost reduction, communicating that this is happening, and convincing investors and policymakers that actually they can afford it. You mentioned quite rightly now we can afford green electricity. Well, it shouldn't be. It shouldn't be an aspect of affordability. We should all be able to have access to a technology or energy that is not only non-polluting, but is also reliable, that is not going to burn, you know, our appliances at home, and that is going to be there when we need it, and that is not going to be only producing whenever the sun is shining and the wind is blowing. We all need to have access to that. And very quickly answering, where are the new disruptors and the new innovators out there? Now the game is about not generating thousands or millions of kilowatt hours in a single power station with millions and billions of investments. As we go distributed, we are talking about that are millions and millions of generators that will produce very little amount of energy in their own place, and whoever is able to actually get that energy distributed smartly, that's where you get your Uber for energy. That's where you are going to get your Netflix for energy. And Peny is working on that, so she is making sure that that is happening, that interconnectors are able to withstand those flows. Have you ever thought the algorithms behind Uber? You know, how is that possible that whenever you click your telephone, it doesn't come across that you actually book the same taxi as other people next to you? You know, this is also going to be applicable when solving algorithms in energy, not only for trading, but also to supply the electricity. So whoever gets the full potential of distributed energy platforms for users, all of us, to be able to buy, share, generate energy with our smartphones, that's where the mind gold, in my view, is.
I would just say that it's also like the customer behavior. So when all of us will try to use these sensors and want to use the smart meter, the electric car, like take advantage of everything, and then being in this distributed environment combined with who would be the supplier that could handle this, then that could be the disruption.
Okay, well, I'll be a disruptor and call the discussion to a close for now. But please join me in thanking the panel. And I don't want to keep you from drinks for too long, but what I would like to do now is introduce the person who had the foresight to set up the course and to speak very briefly to you, Sandro.
Thank you very much. I feel emotional because it's been 10 years. You know, Andy, Peny, Iván, Elena, thank you very much for your being here tonight, for being so, such a great ambassadors for the course. And thanks for me personally for reminding me why it was worthwhile all those years ago to getting out of bed and trying something new and different and so on. It was worthwhile. On this basis was great success. So thank you to you. And thanks also to all the other 418 alumni in the course. Keep coming, keep enjoying, keep going out and doing very interesting things. One of the interesting statistics is that most of the people who have come in the course and doing this are actually ended up in energy, working in various ways, from consultancies to government to technology companies, and stayed in there. Some companies have, keep coming back, ABB and others. So thanks to all the students, you really made the course. Talk about diversity. Part of the challenge in designing the course was to bring in people from different areas. Chemical engineering, mechanical engineering, not just engineering, geology, even the odd economist, geography, one or two, chemists is borderline, but so we bring all these people together and the diversity of the background and starting to talk to each other, and the sparks were flying, and we just had to go beyond the parapet and let the fire go. And I think that was one of the great things to see. But the challenge to bring these people together around a curriculum which everybody could undertake and so on. So that was very interesting. And I must say, when we started, this was about 12, 13 years ago, to think about, in the college, what are we going to do about the big energy challenges. At the time, we came up with the energy futures as a way of addressing the research aspects. But we really recognize that it's not just, how do you build the sustainable energy, but who is going to do it? Who is the Superman going to be able to, or Superwoman, going to be able to address these highly complicated issues, which are really very horizontal, and without going in depth, but have the ability to discuss and to have the language and the background to be able to look at the trade-offs, because it is about trade-offs. It is about things. It's about the language for discussing complexity. Is really a system view, and my own background that came into this. So the focus was on who is going to do it, and that really put a lot of emphasis on then how do we, what do we need, what skills do we need to bring in into enabling people to have this conversation and so on. It was really very interesting, very challenging. This was, and I think still is, the only course within Imperial or anywhere else that I see that involves a dozen departments or 3 faculties. Talking about herding cats, this is and keeping the administrators together. Getting the curriculum was the easy bit. Now getting the underpinning administrative system to enable to manage this and distribute the load and the courses and the money and all that, that was even more challenging. But we managed to do that. So we put together quite a unique course. We knew we were onto something, when the review of the course was sent out to various other people, of course, business plan and all the other. And one of these was MIT. And the people from MIT came back and said, oh, this is a very nice course, but I think it's too difficult. We wouldn't be able to do it because it's just too complicated. So I said, okay, we'll do it. and we will know that there is a threshold there that will keep the competition out. And it worked, because I don't see a similar course anywhere else. There are similar course, but not quite the same way. So that was good. Two questions we had. First is, you do PowerPoint things, and the question was, will they come? A big question mark. Will it be popular with the customers, students? Okay. And we were reassured. We had designed for about 40 people. First year we thought maybe 10 to 15. 24. We had to scramble around to find extra room and desks and other things. So, well, maybe we're onto something. And then very quickly we got up to the steady state. Within 3 years we had 400 applicants. They found us. We didn't go out and advertise. So clearly we hit on something. So will they come? The second is, will they find a job? Because this was a different product. Everybody knew about undergraduate in a vertical, or a very senior person in another person. And we had lots of good conversations, including with ABB. I must say, ABB and others recognize that this is a different product. And they also recognize that the recruitment organization was not suited for that. It was suited for recruiting the undergraduate or recruiting the very senior person with that. And put in place a special recruitment program at the corporate level to recruit people from our course, 3 or 4 every year, at least in my time. And other employers, we work very hard, with the Npower and the other guys who recognize that this is something different here, much to their credit. And now it probably is getting a lot easier because the message is going out, and you are recruiting as well, and so on. So, will they come? Will they get a good job? I'm relieved on both accounts, and there's a great demonstration here that not only they're good to get a job, they're going out and doing a splendid job and getting to making an impact, having effect, really kind of delivering what we were hoping that we would be able to generate and encourage. So great cohort, great team spirit. Being different is always, it's like going through the army together, through battle, it kind of brings you together. And that has stayed on, and it's splendid to see. In many ways, 10 years, as I explained, the battle, things have moved on. You no longer have to explain that you need a sustainable energy future, except for a few flat earthers out there, which are still around and in great power. And by and large, that particular battle has been won. Okay? And we're now moving on to say, how do we now move on and conquer and do things? I have no doubt that whatever the future is, whether it's highly distributed energy or whether it's something, the people will still need the skills to discuss and make choices in a very complex systems. And I believe that the course is delivering this, and if it's, whatever the future might be, I think is in good hands. So thank you very much.